All right, so I said I would record a couple examples from yesterday's lesson on Thursday, November 8th. Again, we talked about graphing linear inequalities, and our solution is always going to be our double shaded region. Sometimes the intersection point will also be part of the solution. Sometimes it won't. When I look at this first problem, problem number 6, I notice that both are in standard form. The first thing we need to do is convert to slope-intercept. And to do that, we have our 6x plus 4y is greater than 12. I'm going to need to subtract 6x from both sides. That's going to give me 4y is greater than negative 6x plus 12. I'm going to divide both sides by 4. And I'm going to get y is greater than negative 3/2 x plus 3. For that equation, I'm going to have a slope that's equal to negative 3/2, a y-intercept of 0, 3. Because it's greater than, I'm going to shade above. And because it's just greater than and there's no equality there, I'm going to have a dotted line. And I'm going to go ahead and graph this in red, starting at 0, 3. I'm going to go down 3 and to the right 2. I can also go up 3 and to the left 2. And that pretty much gives me my graph here. Again, it's a dotted line, so I'm going to connect the dots. And I'm going to shade above. Since this is dotted, by the way, the intersection is not a solution. Anytime at least one of the functions has a dotted line, one of the linear inequalities has a dotted line, it's not a solution. Okay. Let's take a look at the second example, or the second linear inequality, and convert that to slope-intercept form. That's 3x minus 4y is greater than 8. I'm going to add 3x, I'm going to subtract 3x from both sides. That will give me negative 4y is greater than negative 3x plus 8. I'm going to divide by negative 4 on both sides. And because this is a negative, and I'm dividing by a negative, I'm going to flip the sign. So what I end up with is now y is less than, because I had to flip the sign, 3/4 x minus 2. And that flipping of the sign is, again, because of my negative dividing by a negative. All right, so now having looked at that, my slope is 3/4. My y-intercept is 0, negative 2. I'm shading below. And I have a dotted line. So starting off at 0, negative 2. I'm going to go up 3 into the right 4. Again, up 3 into the right 4. I can go down 3 and to the left 4. There's a dotted line. And I'm shading below. As I do that, my solution is going to be the area in black. It is a double shaded region. And some of my solutions could include the point 4, 0. It could include 7, 2. And it could include 6, things like 6, negative 3. The key to this problem, again, is recognizing both are in standard form, converting the slope-intercept form, and then graphing them accordingly. It's also important to remember that when you divide by a negative with an inequality, you have to flip the sign. All right, let's do one more example here. We're going to look at problem number 11, which is 7x plus 4y is greater than or equal to negative 32. X minus y is less than 3. Again, we're going to take our 7x plus 4y greater than or equal to negative 32, and we have to get that in the slope-intercept form. I'm going to subtract 7x from both sides. This will give me 4y is greater than or equal to minus 7x minus 32. Notice I don't combine those into one term. They're unlike terms. Divide by 4 on both sides, and I get y is greater than or equal to negative 7/4 x minus 8. That part of the equation, my slope, m is equal to negative 7/4. It's a negative slope. My y-intercept is 0, negative 8. I have a solid line, and because I'm greater than, I'm shading above. So I'm going to go ahead and graph that. 0, 8. My slope is negative 7/4. I can't really go down 7 to the right 4, but I can go up 7 and to the left 4. All right, solid line. I'm going to try to draw this as straight as I can. Not too bad. And shading above. It's a whole lot of shading that I'm going to have to do here. And I'm good. The other equation, x minus y is less than negative 3. Subtract x from both sides. Negative y is less than negative x minus 3. I have to divide by negative 1 on both sides. When I divide by negative 1, I'm going to flip the sign. And my result will be y is greater than, this in blue, so you see that y is greater than x plus 3. As a result, I have a slope of 1, a y-intercept of 0, 3. I'm going to do above, and it's a dotted line. Starting at 0, 3, I have a slope of 1/1. I'm going to shade above. And my dual shaded region, we'll do in blue, is where my answer will come from. Okay. My solution, the intersection, is not a solution. And it's not a solution because this line is dotted. Dotted lines means the intersection isn't a solution for a system of linear inequalities. My solution points could include negative 2, 2. They could also include 0, 4. 2, 7. And so on and so on. Oh, I didn't draw 2, 7 in there. There we go. All those could be solutions, as well as negative 5, 6. And there's plenty more as well. All right, that should help you with finishing up yesterday's assignment and prep you for writing systems of equations or linear inequalities in context.